Hello everybody, this video today is about acceleration. And acceleration can be quite confusing. So let me go ahead and write that on here. E-R-A-T-I-O-N. Okay, so as you know, I'm a horrible speller. That should not be a secret to anyone by now. Okay, so let me tell you what acceleration is. Acceleration is defined as the change in the velocity. So the definition is the change in the velocity. Now many students kind of get this confused with velocity. Acceleration is not velocity. Basically, in layman's terms, acceleration is how fast you get fast, or it could be how slow you get slow. It's how quickly you change that velocity. You can change, and of course velocity is a vector, so you have to also pay attention to the direction. So not only is it how fast you get fast or how slow you get slow, but it also can refer to how quickly you change your direction. So it can be how fast you get fast, how slow you get slow, or can change your direction. So acceleration has a magnitude, it has a number, and it has a direction. So acceleration is also a vector. Meaning you have to pay attention to the magnitude or the size, the number. It has a magnitude and it has a direction. It has a direction. So what I mean by magnitude and a direction, magnitude means it has a number, it has a size. Is it 4? Is it 5? Is it 6? That's magnitude. The direction is the sign. Is it to the positive direction? Is it to the negative direction? So that is what I mean by magnitude and direction. And that is the definition of a vector. It has a magnitude and a direction. So let me go ahead and give you the unit for acceleration. The unit is meters per second squared. So it's how fast you change that velocity. And so the layman's equation, I'm going to start with the layman's equation, and then I'm going to get a little deeper and get a little detail. So the equation, let's start out. It's how the velocity changes. It's how fast you get fast. So A is the change in the velocity, and it's how fast you make that change. And so you have to do that change in a unit of time. If you change your velocity in a short amount of time, that means you're getting fast really quickly. That is a large acceleration. If you change that velocity in a large amount of time, you're getting fast in a slower pace, but it also is also defined as acceleration. So I'm going to break this down right here. Delta V is defined as final minus initial. So A is final velocity, and for us, we're going to call final velocity VF. The initial velocity, which is the first one, we're going to call VI, over the time it took to make that change. Oops, sorry, that was the light. It went out. I guess there's no motion in my classroom because I'm just sitting here. But that is what acceleration is. I'm going to clean that up, and I'm going to make it in the basic form. Now, the basic form reflects the velocity, the final velocity. So the basic form we're going to use is VF, and I'm going to say it is VI plus AT. So we have done some literal equations, and I rearranged it to solve for the final velocity. And so this is our basic form. And from there, we can change the equation around to get whatever it is we're looking for. Because normally when you're working with acceleration, what you're after is, what is the final velocity after I've changed my velocity? What am I now going? How quickly or how slowly or in what direction am I now going when I apply this acceleration? So that's why the equation is reflected in this form and not this form. So that is acceleration. So I have some pictures here, and I'm hoping it will kind of clarify and give you some more idea on what's going on. All right, so here I have a car, and actually let me show you this one. This one shows a negative acceleration. Let me show you this one first. So I have a car, and a car at the beginning is going 15 kilometers per second. This unit is kind of odd. All of your homework will be in meters per second. But if I have an acceleration rate, let's see, after 1 second, it is going 15 kilometers per second. That's the acceleration rate. So initially I'm stopped. I'm going to change this velocity by 15 kilometer per hour second. Again, it's kind of odd. And we can talk about that in class on Monday. So this is constant. This doesn't change, okay? This is called constant acceleration. So that doesn't change. Which means after the first second, I'm going 15 kilometers per hour. I'm going to change it again in the second second by another 15 kilometers per hour. So which means in second 2, I'm going 30 kilometers per hour. And if I go to second 3, it'll be 45 kilometers per hour. Second 4, it would be 60 kilometers per hour. At second 5, it is 75 kilometers per hour. So I am changing my speed by 15 kilometers per hour for every second that I'm on the road. So that's what this handout is showing, and that is what acceleration is. It's how fast you are changing that velocity. Now, since acceleration is a vector, it can point in a positive or a negative direction. So, let me show you this, give you something to think about. If I have a car, and I'm going to do a crude drawing, bear with me. If I have a car, headlights, and the car is going this way, the velocity is in this direction, and let's just say it's 10 meters per second. Okay, if I change my velocity in this direction, would I end up going faster or slower? So pause the video for a second and think about that. If you've thought about that, you're going to end up going slower, because these two arrows don't agree with each other. They don't support each other. One is working against the other, and so you're going to go slower, which means this velocity is to the right and it's positive, and this change in the velocity is to the left. It's negative. If I change my velocity in some unit of time that way, negative direction, I'm going to end up going slower. And the longer that time, the slower I go. So acceleration has a magnitude and it has a direction. I hope everybody is clear on that. So if I have my car now, watch this. This might be a little interesting for some of you. Let's say I'm going this way. Velocity is in this direction, and that's a negative direction. If I change my velocity also in the negative direction for some amount of time, I'm going to end up going faster. And some of you are like, how can two negatives make a larger number? Remember, the negative signs indicate the direction and not the size of the number. Since these two arrows point in the same direction, they agree with each other. They add up together. They piggyback on each other, which means I'm going to go faster. So here's an idea. If the sign on the velocity and the acceleration agree, that means you're going to go faster. That equals faster. Okay? And if the sign on the velocity and the acceleration disagree, that means you're going to end up going slower. Okay, so these are really two good rules of thumb on velocity and acceleration and the signs associated with them. So keep that in mind. All right, so let's go to another aspect of velocity, acceleration now, and velocity. And there's one more thing to think about. If I'm traveling along, even if I accelerate, if I end up going faster or if I end up going slower, what's going to happen is I'm going to cover some distance. I'm going to cover some distance. I'm going to cover some displacement. So here is my car. I'm going to go this way. My velocity is in the positive direction. And then I'm going to accelerate. I'm going to change my velocity for some period of time in that direction. I'm going to go faster because the arrows agree, the directions agree. I'm going to go faster. And when that happens, I'm going to cover a lot of displacement. And there is an equation to determine how much I cover. What is the change in my displacement when I have acceleration? And the equation is the change in the displacement, delta x, is equal to the initial velocity times the time of acceleration plus 1/2 times the acceleration and the time squared. This gives you displacement. That's what delta x stands for, is displacement. Okay, so I've given you two equations in this lecture, and you got one from the one prior. I'm going to give you one more. And the last one is how do you solve all of these problems if you don't have the time? And there is an equation around that. Of course, in physics, we have an equation for everything. And so the equation when you don't have time, if you don't have time, t, you can use v final squared is equal to v initial squared plus 2 times the acceleration times the change in the displacement. And from our literal equations, these should look familiar. Well, I've given you 3 equations. You got one from the previous video, which gives you a total of 4. If you can master these 4 equations, then you will be prepared for the test. And the test is coming up. It won't be next week, but it is coming, so be aware of that. Again, if you have any questions, jot them down to the side and bring them to class, and we'll discuss them and we'll clear them up. The next video, which you are required to watch, is a video on sample problems using these equations. Please watch that before you come to class on Monday. Good luck, and again, write your questions down if you have any, and I'll see you then.